Hello, this is Atarneem Qureshi. In this video, I'm going to educate you about atomic structure. Let's begin our lecture on this topic. Dear friends, whatever we see around us is called matter. The chair, the clouds, the water, everything that has mass and takes up space by having volume, either solid, liquid, gas, or plasma, is called matter. Now, when everything is matter, then why all these things are different from each other? It is because every matter is composed of different elements. Elements like hydrogen, nitrogen, oxygen, and carbon, etc. There are 118 elements discovered right now. An element is a pure substance consisting of only atoms. An atom, which is the smallest unit of an element, these atoms are extremely small that under most definitions the radii of isolated neutral atoms range between 30 and 300 picometers. Generally, the atoms of noble gases can exist independently, but the rest of the atoms cannot exist independently. Atom is now further divisible into subatomic particles. More than 100 subatomic particles are thought to exist in an atom. A few subatomic particles are electron, positron, neutron, hyperon, neutrino, antineutrino, etc. Whereas electrons, protons, and neutrons are called the fundamental particles of an atom. Now, let us look into the brief history of atom. Earlier, it was thought that matter was made up of simple indivisible particles. Greek philosophers thought that matter could be divided into smaller and smaller particles. Thus, a basic unit could be reached which cannot be further subdivided. Democritus called the indivisible particles of matter as atoms. The word atom is derived from Greek word atomos, which means indivisible. By the way, these concepts of Greek philosophers were not based on experimental proofs. Later on in 19th century, John Dalton, an English school teacher, explained the law of conservation of mass and law of definite proportion on the basis of concept of atoms. He developed an atomic theory. According to the main postulate of Dalton theories, all matter is composed of atoms of different elements which differ in their properties. Another scientist, a Swedish chemist, J. Berzelius, also from 19th century, determined atomic masses of elements. Many of his values are very close to modern values of atomic masses. Berzelius also developed a system of giving symbols to elements. A direct evidence of atom can be obtained by an electron microscope. It uses a beam of electrons instead of visible light. The wavelength of electron is not shorter than the visible light. Thus, it is suitable to see extremely small objects. However, a less clear picture of atom is obtained by electron microscope. In 20th century, actual work has shown that the diameters of atoms are approximately 2 into 10 raised to power minus 10 meter, or you can say 0.2 nanometers. And masses of atoms range from 10 raised to power minus 27 to minus 25 kilograms. Generally speaking, a full stop may have 2 million atoms present in it. Let's look into the structure of an atom. Every atom has nearly all of its mass concentrated in a tiny region in the center of atom called nucleus. This nucleus is made up of two kinds of particles, protons and neutrons. Collectively, these particles in the nucleus are called the nucleons. Atoms of different elements have different numbers of protons. And outside the nucleus, particles called electrons, which move around in region space called orbitals. These orbitals are also called shells. Each shell is a certain distance from the nucleus at its own particular energy level. It is important to note that in a neutral atom, the number of electrons is always equal to the number of protons. Atoms are very small, but the nucleus of an atom is even too smaller than atom itself. For example, if the diameter of an atom could be the size of a football stadium, then the nucleus would only be the size of a choco bean, which means that most of the atom is an empty space. And electrons are even smaller than protons and neutrons. Electrons, protons, and neutrons have their characteristic charges and masses. The values of these are too small to be very useful when discussing general chemical properties. For example, the charge on a single electron is minus 1.602 into 10 raised to power minus 19 coulombs, We therefore compare their masses and charges by using their relative charges and masses. Because of their relative masses and charges, these three particles behave differently in electric field. Neutrons are undeflected, being electrically neutral. Protons are attracted towards the negative pole, which means that protons carry a positive charge because of the matter of fact that opposite charges attract each other. On the other hand, electrons attract towards the positive pole, and which means that electrons carry a negative charge. If their initial velocities are the same, electrons are deflected to a greater extent than protons because they are much lighter in size. You should memorize this table showing the charges, masses, and relative masses of electrons, protons, and neutrons. So, from all this discussion, we can conclude that atoms are small spherical structures with diameter ranging from 1 into 10 raised to power minus 10 to 3 into 10 raised to power minus 10 meters. The particles that contribute to the atomic mass are contained within a very small central nucleus that has a diameter of about 1 into 10 raised to power minus 15 meters. The electrons occupy the region around the nucleus. They are to be found in the space inside the atom, but outside the nucleus, which as a whole is called the atom. All the atoms of a particular element contain the same number of protons, which is equal to the number of electrons within those atoms. Atoms of all the elements except of hydrogen contain neutrons. These neutrons are in the nucleus along with the protons, and the only effect that these neutrons have on the properties of an atom is to increase its mass. So guys, that is for today's lecture. I hope you have liked it.